I fear I've gotten to the age that even music that I was listening to and loved when I wasn't even young anymore is now already out of date. And so I fear that there are many students out there who have never even heard of Prince, which is a perfect segue, I think, into today's lesson about sign diagrams because it is a dying art. Um, Now that we have a lot of technology at our disposal, we can simply graph these functions, and Conrad Wolfram would probably be upset that we're even doing this lesson anymore. But we are, because of a couple of reasons. You will be still required to do some curve sketching, so trying to figure out the shape of curves without the use of technology. Um, it's still on standardized tests, and because it's kind of still a good practice to learn and think about the shape of graphs. So we'll move forward. One of the main aspects about curve sketching is that it gives us a quick and easy way of figuring out the general shape of a graph just by finding a couple of key or critical points uh, that we can use to sort of help us find out what the rest of the graph looks like, and provides us with enough information that it is pretty much all the information that we need to be able to move forward with our calculations. So the critical points that we need specifically are the x-intercepts and points where the function is undefined. So what is a sign diagram? It's basically a horizontal number line, the x-axis, and on the x-axis we only highlight the specific numbers that indicate where an x-intercept is, or a point where the graph goes undefined. And then between those numbers we place positive and negative signs to indicate whether the graph is above or below the x-axis. So let's take a look. Here we have a function, and here's the graph. And if we were to take the graph and create this sign diagram, we see that the graph crosses the x-axis at these 2 points. These are the only two numbers that we need on our sign diagram. We don't need the y-intercept, just the x-intercepts. There's no place where this function is undefined, so these are the only two numbers that we need. And since the graph is above the x-axis here, we put a plus, below minus, above plus, and then that's it. So this sign diagram tells us pretty much all that we need to be able to do any further calculations, especially when we're doing calculus and we're trying to find maximum and minimum points. Again, here's another function, and we see that the function just intersects the x-axis at only one point. This shouldn't surprise us because we should be able to see that this is a quadratic. It's a parabola, and we've just flipped it upside down and we have moved it to the right one. So the vertex is still on the x-axis, and so we have a critical point here, and the graph on both sides of this critical point are both below the x-axis, so we actually have two of the same signs here. Here we have a function that has an undefined point at x equals 0, and so we indicate that. Notice that it's a dotted line here instead of a solid line, a solid little mark, and then our two positive and negative signs. So the book wants us to formalize these observations. If a factor has an odd power, so these are factors, this is a factor, this is a factor, these are both raised to the 1 power, so they're both odd. And so what we're saying here is anytime that we have a factor to an odd power, the function will pass through the x-axis. Here we have a factor that's to an even power, and that means that it doesn't pass through. It just is tangent to the x-axis and continues back in the same direction. So those are quick observations. One more thing. we have to make sure that we understand that we don't we create sign diagrams because we don't have the graph. So we're just using the graph to make a connection between the sign diagram and what the graph looks like, so that when we try to practice this without being able to see the graphs going from the function directly to the sign diagram, we really know how to do that a little bit better. So let's see a couple more examples. Oh, wonderful picture. Anyway, so here we've got a function, looks like a cubic function, and it passes through the x-axis at these 3 points. All right, and they're labeled here. We can't see it, but that's a -2, and that's a 1, and that's a 4. So those are the only 3 points that we need to indicate on our sign diagram. Again, we don't need the y-intercept, just the x-intercepts. It's a continuous function. There's no undefined spot, so that's it. So each of these spaces on either side of the numbers need to be filled with a plus or minus sign depending on where the function is above or below the x-axis. And so we place the numbers like this. Over here we have another function. Here we've got an undefined point right here at x equals -2, an intercept at x equals 1/2, another undefined point at x equals 3. Those are our 3 points, and then again the plus or minus signs in between those points indicating the position of the graph above or below the x-axis. So now let's try this without a graph. So here's a function. Take a minute, pause this video, take a minute to try to figure out this sign diagram. Hopefully you recognize that this is a quadratic, and we have it in factored form. So what we can do is we can find the x-intercepts. So this has to be -3 and this has to be +1. And then because this will be a positive x squared, we know that the graph will kind of look like this, U-shaped right there. So then we have a positives on this side, a negative on here, and a positive here. All right, and if you didn't recognize that this was a quadratic, then you could still plug in numbers on either side of the numbers that are the critical numbers. So any number that's bigger than 1, you can go ahead and pick. Let's just pick 2 because it seems easiest. Substitute 2 in for x, and you get a number that is, well, you don't even have to figure it out. You just, as soon as you know that it's greater than 0, you know your graph went above the x-axis, so you can go ahead and indicate a positive sign here. A number in between here is 0 is an easy one. If you substitute 0 in here, you get 3 times -1. That's a negative number, so you know that there's a negative sign that goes here. And then finally, any number that's less than -3, so -4, for example, substituted in here. -4, so that's going to be -1 times another negative. A negative times a negative is a positive, so we put a plus sign here. So you can actually take points, sample points, to figure out whether the graph is above or below the x-axis, and then put the signs in. Okay, try it for this. Go ahead and press pause. Okay, again, we have another quadratic, so we know that we have some sort of arcing graph. There's a negative sign here, so it should be arcing it in this way. Let's take a look. We can go ahead and do some factoring if you like to try to figure out where the x-intercepts are. And we find out that the x-intercepts are at positive and -2. And we can test points to see where the graph is positive, where it's negative. If we notice that that's a negative, so it's an arcing, it's sort of an arcing through these points. It'll look something like this. So then the graph is below the x-axis here, so we indicate it with a negative, above positive, below negative. So this is our sign diagram. Again, you can substitute values in once you know your critical points, -2 and +2. So for example, the next number that's larger is maybe 3. If I substitute 3 here, I know 3 squared is 9. 9 times 3 is going to be something that's bigger than 12, so that gives me a negative sign here. 0 is a good number to pick between here, so this becomes 0. So we get a positive value here, and then picking, say, like -3, substituting in here, you get a negative number, a large negative number, and so that becomes negative. Let's try one more. Oh, I didn't do an animation here, sorry. So I don't know why I'm getting this. Anyway, well, we can see that this function is written right here. So it's x minus 1 in the numerator, 2x plus 1 in the denominator, and we want to make a sign diagram. We know this is some sort of reciprocal function, so we're going to have some undefined spots. So let's make sure that we find that. What will make this denominator equal to 0? Well, we write 2x plus 1 equals 0, and we solve, and we should get x is equal to -1/2. So that's going to be one critical point. Where does this function cross the x-axis? Well, when this whole function is equal to 0, and so we set this function equal to 0, and we can solve, and then that should give us our other critical point. So we can multiply both sides by 2x plus 1, solve, and you get x is equal to 1. So those are our two critical points. Again, because this indicates an undefined spot, we make this dotted. This is an x-intercept, so that's solid. We only have two numbers here, so what we need to do is test some numbers in between to see if it's positive or negative, and then you go ahead and indicate the signs this way. Okay, hopefully that was clear.